From the moment the universe burst into existence more than 13 billion years ago, it has been expanding with galaxies visibly flying apart from each other. Astronomers have tried to measure one of the most important numbers in cosmology, the Hubble constant, which describes how quickly expansion is happening. Radio telescopes are the world's most sensitive radio receivers. They investigate the growth history of galaxies. Researchers measure the rest frame radio, ultraviolet, UV, as well as optical sizes of 98 radio-selected, star-forming galaxies. They are capable of finding extremely faint wisps of radio emission. That comes from objects that are the farthest reaches of the universe. Many galaxies are faint that collecting enough light to produce a detailed spectrum is impossible. Astronomers thus have to use a much rougher guide for estimating what kinds of stars inhabit the faintest galaxies and their overall colors. But recently, Jansky's Very Large Array, VLA, used help from nature to detect a distant galaxy. It is probably the weakest radio-emitting object ever discovered. Astronomers say that clusters of galaxies are used as gravitational lenses. Gravitational lensing refers to the gravitational bending of galaxies in a cluster. It amplifies light and radio waves from distant objects. Astronomers noted that the large visible red-orange objects are radio relics. Large structures may be caused by shocks inside. The foreground cluster known as MUXJO 717.5 plus 3745. Data revealed a galaxy that is more than 8 billion light-years distant. Its light and radio waves are bent by the gravitational lensing effect by the galaxy cluster in front of it. The more distant galaxy is called VLJ 71736.66 plus 374506.4. It has been magnified more than 6 times by the gravitational lens. This allowed the VLA to be able to detect it. The galaxy is 300 times less massive than the Milky Way. Such observations show that as the universe ages, the scale of the Milky Way galaxy is also expanding. The number of gas-rich galaxies, especially with less luminosity, is much greater than today.